Just
This is why I stopped to just make it recording now. Okay. So we said really we cannot start triple integrals geometrically because we cannot graph functions of the three variables. So we just follow the procedure we did with double integrals, i.e. just you do triple Riemann sum, you find the triple Riemann sum of the solid. Okay, you just divide it, you take boxes, you take h, then you find Riemann sum, triple Riemann sum of the function. When you take the limit, you get h triple integral. So the definition is given as just a limit of a triple integral. The definition of the triple integral is given as a limit of triple Riemann sum. Okay. This is the definition. But then we have two formulas, and they are generalizations of those in double integral. So triple integral of 1, if the function is 1 over d, you get volume of d. And this is a generalization of those given in double integral. Okay. Take the double integral of 1 over r, you get area of r. If you take the single integral of 1 over an interval, you get length of the interval. Okay. Yes.
لو سمحت ممكن تكبر الصورة.
Okay. Then we have the second formula, average value 1 over the volume of d, triple integral of f over d, which is also a generalization of those in double integral and in math 102. Okay. Now, today we'll concentrate on number 2, يعني volume of d. So this is يعني pay attention. Okay. Today we'll just see the importance of formula 2 today. Okay. This is really the application of triple integral. Number 3 is just a formula. يعني there is nothing new in it. Okay. It's generalization of these two from math 101, from math 102 and double integrals. Well, then we said as in double integral, the main problem is to set up the limits of integration, and to set up the limits of integration, it depends on the solid D. If D is a rectangular box, then we set up the limits of integration easily by taking dv as any of these possible orders, i.e. the order dx, dy, dz is not important. You can choose any order, okay, which is like really the situation in double integrals when the region R is a rectangular region. The order is not important. Here, if D is a rectangular box, the order is not important. You can choose any order, okay, then evaluate. Then we went to the general case when D is a general case, and we consider solids of type 1. Geometrically, a solid of type 1 is a solid between two surfaces, G1 and G2. To set up the limits of integration, we need just to describe the solid. If the solid is parallel to the z-axis, we start describing with z. Okay, we're describing the solid by the first describing z. What are the limits of z? They will be between the lower and the upper surfaces. Between the lower and upper, so z between G1 and G2, the lower surface and upper surface. What about xy? The other two coordinates. We just take the projection of the solid in the xy plane. This is the projection. Or while saying, what are the xy points of this solid? What are the xy points? Or what is the xy region of this solid? This is the projection. Okay. Then to set up, we have to start integrating with respect to z from lower to upper, G1 to G2. The other two, the double over the region R. After we finish integrating the inner, we end up with a double integral. And to set up the limits of integration for a double integral, we use whatever we did in the previous sections on double integral. Okay. is R is a rectangular region, or is it a region of type 1 or a region of type 2? You decide what it is, and then accordingly you set up the limits of integration. Okay. So after you finish the inner, evaluate the inner, you end up with a double integral. So as I said before, in every problem in triple integral, you will use double integral. So it depends also, double integral is a prerequisite. You have to use double integrals. Okay. In fact, so in the examples we are reviewing also double integrals. Okay. We gave one example about evaluation. Okay. To set up, I have to sketch the solid, and we mentioned really you have just to go and review or recall the basic graphs in section 12.6. Okay. There we gave the list of the basic graphs: planes, cylinders, and quadric surfaces, paraboloids and cones, and etc. Okay. So it is very important that you spend some time just recalling section 12.6. Okay. Once you know how to sketch the solids, really it is not difficult to decide what is lower, what is upper, what is left, what is right. They are easy usually. Okay. So you have to sketch 12 point. You have to review section 12.6. Okay. Now this is H evaluation. So this is what we did last time. So I will not, of course, go through it. Now we give another example still. So we stopped here. Now we continue now with another example. So let me give you H an example here. A new example. Okay, so find the volume. The volume of the solid enclosed by the surfaces. Z equals 2x squared plus 2y squared, and Z equals 9 minus x squared minus y squared. Yes. Pay attention to this. This is actually a very important example. Now I will mention something new. Okay, so pay attention. Okay, before I solve this, I will just go back just to recall certain things. Pay attention. Now we will get something new, so it is very important to pay attention. Okay, just let me just recall the following. Math 102. The main problem was area. And the two situations are the following. Okay. You have one curve over an interval. Okay. Over an interval. So we need to find this area. Or another situation, it is an area between two curves. Either an area of a region below one curve above an interval, or an area between two curves. These are the basic ones in Math 102. Now, when you go to Math 201, okay, you have the main problem is volume. Now you have the following. I will have a surface, one surface, Z equals f of x, y, and I have a region here. And I need to find the volume of the solid between above the region and below the surface. I need to find the volume of the solid. This is what we did really in double integrals. So the volume will be a double integral over R of x, y, dA. And by now this formula should be trivial to you, because we were discussing this during the previous 2 weeks. Okay. So the volume of the solid below a surface and above a region, double integral. Okay. Okay. Now, what about the following? The new thing now. The new thing. Okay. Now we have a surface here. Z equals G2 xy, and another surface here. Z equals G1 xy. Okay. And I need to find the volume of the solid here. Okay. D. The volume between two surfaces. Between two surfaces. هنا a volume between a surface and a region, or above a region, one surface. هنا a volume between two surfaces, okay, very different. Here in this case, it is better to use a triple integral over d of 1 d dv. Okay. I.e. will use the second formula above. Okay. You see here now. لاحظ هنا الآن volume of d triple integral of 1 okay. But this is where we will use triple integrals, the geometric application of a triple integral. When you take triple integral of 1, you get the volume of any solid, any solid. Okay. So this is where we use this formula here. So when you have a solid lying between two surfaces, it is better to use a triple integral and use this formula here. طبعا even here when you have one surface, in fact we can solve this one using also triple integral. And really this is a generalization of this one. Okay, but it is always better just to keep the work shorter for you. You have these two cases for the volume problem. If the solid is between one surface and above a region, use double integral. If the solid is between two surfaces, it is better to use the triple integral. Okay. This is the summary of the volume problem in chapter 15. Okay. Now we go to our example. Find the volume of the solid enclosed by the surfaces. As usual, the first thing you have to sketch the solids. And this is x, and this is y, and this is z. Okay. You have basic graphs. This is 2x squared plus 2y squared. This is a paraboloid opening upward. So this is a paraboloid. Okay. And 9 minus x squared minus y squared is an inverted paraboloid. So this is 9. You have something like this. And they intersect somewhere here. Okay. They intersect here. So you have a paraboloid opening upward. So this is the graph of this one. And a paraboloid inverted downward. One is opening up, one is opening down. Okay. Now we need to find the volume of the solid between them. Okay. Okay. This is the solid. Okay. This is the solid. And inside, everything inside the lower and inside and also below the upper. Everything inside is okay. But this is the solid. Okay. Now the solid between two surfaces. Now I start with the formula. What is the formula for the volume here? Okay.
The third integral.
Do you need to use double integral or triple integral?
Triple integral.
Why triple integrals?
Because two surfaces.
Two surfaces. You have a solid between two surfaces. So it is better to use a triple integral. Okay. When if you have two surfaces, it is better to use a triple integral. Okay. So this is now the formula triple integral over the solid d of 1 d dv. Okay. Now I go and describe the solid so that I can set up the limits of integration. So I go with describing the solid. So this is d. Well, this is a solid of type 1, so I have to know what are the limits of z. What is the lower surface in this solid here? What is the lower surface?
2x squared.
Yeah, 2x squared, 2y squared. What is the upper surface? The other one, 9 minus x squared minus y squared. Okay, so these are basic graphs. And do you feel you have to be a genius to know what is the lower and what is the upper?
I think this is the clearest one.
Okay, this is okay. Now, if it is not clear, but also we said if it is not clear, you can always convince yourself by taking a vertical line parallel to the z-axis. Okay, a vertical line. I enter here and I leave here. I enter through the lower 2x squared plus 2y squared. So this is the lower limit. I leave it through the upper 9 minus x squared minus y squared. So this is h, the outer, the upper. Okay. If it is not clear, you can always do it in this manner. Okay. Now this is h for the lower and upper. Now this is for z. Now x and y in r. I need to find r. Okay. So here just pay attention, Anna, just because this is h. When we have the general situation here, we take R to be the projection. It seems from the general description, it seems R to be very, very difficult to find. But in fact, no, it is not difficult to find the region R, the projection, the XY region of the solid. How to find it in practice if it is not clear? Okay, you do it in the following way. Okay, to find the region R here, find the intersection between the two surfaces. Okay. What is the intersection between the two surfaces? Okay. How to find the intersection between the two surfaces?
Equal them.
You equate z with z. Okay. So you say z equals z, and this implies that 2x squared plus 2y squared equals 9 minus x squared minus y squared. And this implies 3x squared plus 3y squared equals 9. And hence, when you divide by 3 with x squared plus y squared equals 3. So you have two paraboloids. When I find the intersection will be a circle. But where is the circle? This is the circle here. Okay, this is the circle. They intersect here. صح ولا لا? Okay, this is natural. This is the intersection. Okay, they intersect here, and this becomes a circle. Okay. Now, how to find the projection? We'll just bring the circle down in the XY plane. So just bring it down. Project, bring it down. Okay. You get edge, this circle. Okay. And this is the projection. Okay. This is the projection R. This is edge R. Okay. So you find the intersection. It will be a circle in some floor, second floor, third floor. Here it doesn't really important. It is not important. But this is the intersection. Bring this in circle, the intersection in the floor. It will be here, it is edge, a circle. So this is R. Now, if you take any point x, y, z here in this x, y, z, when you bring that point in the XY plane, it will be inside the disk here, inside the circle. Okay. X, Y, Z, X, Y حيكون here, X, Y, Z here, X, Y حيكون here. The projection will be inside this circle. Okay. So this is H, R. So I bring R here. This is R. It is a circle of radius 3, so this is a circle of radius 3. This is 3, and this is 3, and this is H, the region R. Okay. Limits of Z and XY are here. Okay. Now I will just go and write the limits of integration. I will leave R for a while, just leave it. I know now what is R now. So now triple integral, it is a region of type 1. So I will H, first H, integrate with respect to Z. So this is 1 dz. Okay. What are the limits of Z?
بس القطر 3 ولا جذر 3؟
جذر 3. روت 3. فناو limits of I have to integrate with respect to Z. So حتكون what are the limits of Z? These are the limits. Okay, so 2x squared plus 2y squared over 9 minus x squared minus y squared. Okay, then I leave the double integral over r dA. Okay. Before I set up the limits of integration for double r, the double integral, just evaluate the inner, evaluate this one. So this is H becomes, okay, integral of 1 dz حيكون z from z equals 2x squared plus 2y squared to z equals 9 minus x squared minus y squared. So this becomes 9 minus x squared minus y squared minus 2x squared minus plus 2y squared. So this becomes 9 minus 3x squared plus minus 3y squared. Okay. And the value of the inner integral is the following. So a double integral over r 9 minus 6 squared minus 3x squared minus 3y squared d dA dA. After integrating the inner, I end up with a double integral. Now I go and describe R. R is a disk or a circular region. Well, how to describe this region? Which is better, to use rectangular coordinates or polar coordinates?
polar coordinates.
This is what we said in the previous section. If you double integrals in polar coordinates, if the region is a circular region, it is better to use polar coordinates. Okay, the evaluation becomes easier. Okay, so I need to know what is the equation of the circle. So this is h r squared equals 3, and hence r equals √3. And this is r equals √3. Well, how to describe r between what, and theta between what and what. Okay. And now the limits of r. How to find the limits of r? I take a ray from the origin. Then it will go from 0 to √3. 0 to √3. What about theta? You are covering the whole circle, the whole disk. Okay. Then 0 to 2 pi. 0 to 2 pi. So you decided to, then I have to convert everything to polar now. Okay. But this is 9 minus 3r squared. What is dA in polar? It is r dr d theta. Limits of theta 0 to √3. Limits of r 0 to √3. Limits of theta equals 0h to 2 pi. Okay. Now it is very simple to integrate, and you end up with the following, the final answer be 27 over 2 pi. This is how to evaluate. Okay, so finding the region R usually by the intersection, by finding the intersection. Okay, and then you just bring the intersection into the plane. Okay, now also just pay attention here. When after you evaluate the inner, we'll end up with a double integral. For the double integral, to set up the limits of integration, you can use rectangular coordinates or you can use polar coordinates, depending on the region. If the region is circular, it is better to use polar coordinates. So in this example, we use polar coordinates. In the previous example last time, the region was a triangular, so we did not use polar, we use rectangular. Okay. So after you evaluate the inner integral, you end up with a double integral, and then you are free to choose either polar coordinates or rectangular coordinates based on the situation or the shape of your region. Now, if this is clear, this is the end of this example. If this is clear, please write 1 in the chat. If it is not clear, you can ask now. Okay. Now, هنا to make life easy for you. Okay. طبعا هنا to simplify things for you هنا. Okay. I will do something هنا. الآن, this is for this example here. So now for quiz number 5, okay. Now for section 15.6, it is up to solids of type 1. Up to this type. Okay. Now I will go to solids of type 2 and type 3. They will not be covered in the quiz. Okay. So just concentrate until solids of type 1. Okay. Okay. And this is just to make life easy for you. Concentrate on solids of type 1. Okay. Now there is just an observation here, and before I continue the section here, I noticed, some of the students, I don't know how many students, but they have not started even reading chapter 15 yet. Okay. They have not started reading or studying or reviewing chapter 15. In that case, yes, they want to make the quiz after to postpone the quiz even after the final exam. Okay. You want to just delay it until they are ready to prepare for the quiz. But it is dangerous. Now we started chapter 15 more than 2 weeks ago. So you should be able, you should have started reading and reviewing chapter 15. You shouldn't just wait until the day of the quiz. And then you drag about postpone. Okay. Besides, if you really followed me in the explanation in the lecture, if you are really following me, you see things are not difficult. Just know the basic graphs. You don't need to be a genius to know what is the lower surface, what is the upper surface, what is the lower curve, what is upper curve, what is left curve, what is right curve. All of these are natural. Every baby knows how to distinguish between these. Okay. Once you know the basic graphs, okay. So just go and you should have started working on chapter 15 long time ago. Otherwise, even the easy things becomes difficult. They are not difficult because the problem is difficult. No, because you did not prepare well. You did not start early. Okay. You wait until you delay the review and the study of the sections until a quiz or an exam, which is not okay for you at this level. Okay. Also remember in all of my previous quizzes, I ask you always about the basics. Okay. So if you know the basics, you should do well. Okay. Even in the next quiz number 5. Okay. I ask you about the basics. Okay. But you should do well if you prepare, if you studied. Okay. But if not, then you should blame yourself. Okay. And go and concentrate on the basics. Okay. Now let me go now to solids of type 2. Solids of type 2 here, solids of type 2. Okay. In fact, if you know the details, if you understand what we did for solids of type 1, really it will be the same for solids of type 2. Well, how? Just pay attention هنا. This is إيش. For solids of type 2, I have the following. So you have a surface here and another surface here. Okay. And this is H, this is the X and Y and Z. This is the solid. Okay. A solid now parallel to the x-axis, along the x-axis. Solid is of type 1, it was along z-axis, parallel to the z-axis. Now along the x-axis. فهنا the equation of this survey هيكون x equals h1 yz. The equation of this survey هيكون x equals h2 yz. Okay, so we need to describe this solid. We need to describe this solid D. Okay, so this is D. Okay. For solids of type 1, since it is parallel to the z-axis, I have to start describing it first with respect to z. What are the limits of z? Here it is parallel to the x-axis. I have to start describing x. What are the limits of x? Okay. I start with x if it is parallel to the x-axis. Now, if you understand what we did with type 1, what do you think? What are the limits now for x here? If you take any point here, okay, let me take just. If you take this point here, x, y, z, x, y, and z. What are the limits of x? Can you make a guess? What are the limits of x? From what to what? From h1 to h2. You go in the positive direction of the x-axis, in the increasing direction of x-axis. So you enter through the solid here, you enter the solid. Okay, you go in the increasing direction of x. I enter through here, I enter the solid here, and I leave here. So this is the lower, and this is the upper. Okay, h1 to h2. X will go from h1 to h2. This is h1 yz to h2 yz. Okay. This is for x. What remains is yz. So I write y and z. Where yz will lie, okay. The yz region of the solid. We take the projection in where, okay, in the yz plane. In the yz plane. Okay. So you take the projection. This is the projection here. This is the projection. And this is H, the projection, and this is R, okay. Why is it in R, okay? You take the projection, it is along the x-axis, so you take the projection and then why is it a plane? Why is it a plane? Okay. In this case, what is the double integral over d of f dv? I have to integrate first with respect to what? Okay.
With respect to x.
With respect to x, with respect to dx. dx, okay. From h1, yz to h2, yz. The double integrals are left over r dd. This is how it is. It is exactly like type 1, but it is now along the x-axis. This is it. Yeah. There is nothing really new, okay, except and describing the surfaces, okay. And this is z a function of x1, now x is a function h of y and z, okay. And the idea is the same. And in essence, it is the same idea. It is h the same idea as type 1, okay. What about solids of type 3? It will be h a solid parallel to the y-axis, parallel to the y-axis. So the solid will be either along the z-axis or along the x-axis or along the y-axis, okay. These are the possibilities, okay. So solids of type 3, I will not write it here. So it is given in the note. You can look at it in the note or the textbook because it is the same, okay. So let me give you an example about solids of type 2. Okay. Example here. Fine, or just to make things quick and short, because really the idea is to set up. Once you set up, you can integrate, okay. So integration is not the problem, okay. For now, set up the limits of integration. Set up the limits of integration for triple integral over d of f x y z dv, okay. Again, I'm just taking a general function because our objective is not to evaluate, just to set up, okay, where d is the solid bounded by the paraboloid x equals y squared plus z squared and the plane x equals 9. X equals 9. Solution. I need to set up, so I have to sketch the solid. So we sketch the solid. So this is H, the solid here. Okay. This is X, and this is Y, and this is Z. You have X equals Y squared plus Z squared. Okay. Is it a strange surface, or is it a familiar surface? Okay. Have you seen this before or no? It comes from the outer space. Okay. What do you think?
Familiar.
It's a paraboloid. But what is the axis of this paraboloid? Okay.
X-axis.
The x-axis. It is in section 12.6. If you forget, no problem. Just go and recall it. These are very simple. Okay. It is along the x-axis. So this is HD, the paraboloid.
All the solids.
He will not give you solids that you cannot graph. Okay. You have to basic surfaces. Okay. This is H, the graph of this one. Okay. It is a paraboloid still, but H parallel to the x-axis. Okay. Now then a plane x equals 9. Again, you have to know the planes, basic planes, and they are all reviewed in section 12.6. Planes, cylinders, and quadric surfaces. It is a plane, so this is 9 here. It is parallel to the YZ plane, okay. So it will be something like this, okay. It is a plane, parallel to the YZ plane, okay. So this is H, the solid. So the solid is everything inside the paraboloid and to the right of the plane, okay. Everything inside, okay. Well, we go and describe the solid D, okay. It is parallel to the x-axis, so I have to start with the x. Okay. So what are the limits of x? X will go from 1 to 1. Will it go from the paraboloid to the plane, or a plane to the paraboloid? What do you think? Okay.
The paraboloid to the plane.
Paraboloid to the plane. You have to go in the direction of, in the increasing direction of the x-axis. It is along the x-axis. So if I take a line here, I enter here and parabol, and I live here. I live in the plane and I enter through the paraboloid. Okay. فحتكون هنا x squared عفوا y squared plus z squared, and هنا ايش 9 from x equals this paraboloid to x equals the plane. Okay. Now what remains now? Y and z. Y and z, it will be in R, in the projection. How to find the projection? How to find the projection? Okay.
Point of intersection.
You find the intersection. مثل ما عملنا بالضبط فوق هنا يعني. How to find the projection? Just wait, find the intersection. Okay. نفس الشيء بالضبط، لكن بدل ما تشتغل على along the x-axis, you are working along the x-axis. Instead of working parallel to the z-axis, you work parallel to the x-axis or work parallel to the y-axis. It is the same idea. There is nothing new. Okay. So here you are working parallel to the x-axis. You just intersect the projection. I need to find the intersection. So this is intersection. X equals x. X equals x. So this implies y squared plus z squared equals 9. So this is the intersection. This is the intersection here. Okay. Okay. A paraboloid and the plane, they intersect here. Okay. I need the projection. Bring the intersection in the y-z plane. Okay. You bring it now down. We bring it down. And this is H, the situation here. Okay. And this is the projection. Okay. So this is R. Okay. Just bring it here, just to make it here. This is Y and this is Z. Okay. And this is the circle. Center the origin and radius equals 3. Radius equals 3. But this is a 3, and this is a 3, and this is a minus a 3, and this is minus a 3, and this is the region here. Okay. Okay, so this is H, the region. Now I need to describe, let me choose just a different color, just, I need now to describe R. I know now the limits of X. These are the limits of X. Okay. These are the limits of X. باقي الآن dy dz. This is R. So you need to describe this region here. Well, how to describe this region? Do you want rectangular or polar? Okay.
Polar.
Okay. طبعا هنا I can do both طبعا صح. I can do both. لأن okay. I will do both. So just in case. طبعا باعتبار أن هنا I will not evaluate. هنا there is no function. Just setting up. So let me do both. Okay. First let me do it rectangular. Okay. فهنا you have y and z. So I need the outer to be y. Outer. هتكون y. Okay. So what are the limits of y here? Okay. For this solid. The outer have to be constant. minus 3 to 3. minus 3 to 3. لا تنسى ايش؟ الأوتر always ايش؟ constant. صح؟ I need the y interval to be the y interval to be ايش؟ the outer. So minus 3 to 3. minus 3. Now inner هتكون z between what and 1. يعني عندي y and z مش x and y and z. Just you replace changing only ايش letters. Okay. I have to solve z. You solve z حيكون هنا ايش؟ This is z equals root 9 minus y squared. The upper circle, and this is the lower circle. Z equals ايش؟ minus root 9 minus y squared. And if I take x here, for example, y عفوا, this is ايش؟ The lower and the upper curve. The lower is the negative the root, the upper curve is the positive the root. هتكون هنا ايش؟ root 9 minus y squared root عفوا negative and 9 minus y squared. Okay. This is ايش؟ the rectangular description. Okay. يعني حتكون something like this. Okay. Triple integral of f dv over d. Inner of x, y, z. Inner حيكون dx from y square plus z square to 9. Okay, this is the inner. Okay, the outer over R. Okay, so this is ايش over R. So let me see. I said هنا dy, the outer dy, and the inner is dz. Okay, خلاص I work هنا خلاص this is done. Okay, and for R I see the outer is dy حيكون minus 3 to 3 minus 3 to 3. The inner z اللي هم ايش minus the root minus 9 minus y square 9 minus y square. Okay, and this is ايش setting up the limits in this case. Okay, if you want to describe this in R, and this is again very simple هنا. Again just this is ايش. Okay, this is the region. What is the equation here؟ حتكون ايش؟ this is ايش y and z حتكون ايش r squared equals 9 and hence r equals 3. The limits of r and limits of theta. You have a disk. This is ايش not new. So r between what and theta between what and what. If you take a ray from the origin from 0 to root 3, this is ايش 0 to 3. Okay. Limits of theta, you are covering the whole thing, the whole circle. حتكون 0 to 2 by 2 by. يعني by now describing disks or circular regions using polar is not difficult. Okay. This is ايش if you want to use polar coordinates. Okay. This is ايش the end of this section. This is the end of this section. Okay. Okay. So now let me just mention something before you. Again, solids of type 2 is similar, so there is no need to mention it. You can read it from the note or from the textbook. This is the end of the section here, but I will mention something else in the remaining time. Just in a solid, يعني this solid appears in many times in the exams and also in exercises and into the notes. Okay, appears a lot, so it is better to know how to sketch it. Okay, it is not difficult, but it is better to know how to sketch it. Okay. So let me ask you the following. So you have a cylinder, a usual cylinder, a Pepsi can. This is the usual cylinder, and I have a horizontal plane. Okay. Like z equals 1, z equals 2, z equals 3. Okay. Okay. Now, if I cut the cylinder, by this horizontal plane. You cut it by this horizontal plane. What is the intersection between them? You cut it in the middle, for example. What is the intersection between them? Circle. Okay. If you cut it in the middle, the intersection will be a circle. Okay. It will be something like this again. If you put a plane in the middle, this is the intersection. This is a plane. Okay. If you cut it in the middle horizontally, there will be a circle. يعني some figure like the base or the top. Okay. But this is if you cut it horizontal, you get a circle. Yeah, this is obvious. Okay, this is not difficult to visualize. I hope. Okay. Now I will take not horizontal plane. I will take a slanted plane. Okay, a slanted plane. Okay, a plane with a slope, mile. Okay, if you take this with a slope here, what is the intersection? Okay, يعني you cut the cylinder with a slanted plane. Okay, a plane with a slope, mile. Okay, what is the intersection? What do you think?
Ellipse.
Yeah, it will be something like an ellipse. So it will be something like this. Okay, it will be something like this. Okay. It will be something like this. Okay. So this is the intersection at a slope. It will be like an ellipse, not necessarily an ellipse, but like an ellipse. Maybe it is a closed curve now, stretch or whatever. Okay. But it will be something like this. Okay. This is the solid in this case. Okay. But this is the intersection between a slanted slope, a plane, and a cylinder. So this is eventually when we go to integral, and our objective is how to describe this solid now. Describe this solid. Okay. And what is the lower surface? What is the upper surface? And etc. Now, what is the equation of this plane here? You will see it in the example. For example, equals z equals h to x plus 1, or z equals h to y minus 1, or whatever. Really, يعني, for describing D, the solid, this is the solid D. What is the lower? What is the upper surface? Okay. فهنا حيكون هذا ايش؟ Coming from the plane. So this is z equals x plus 1 or z equal حسب البلين طبعا minus 1. يعني in the example you see إنه a cylinder cut by a plane. I need to know what is the equation of the upper surface. It comes from the plane. Well, I didn't care about the equation of the ellipse here or the shape along similar to an ellipse. Okay, I need just the upper surface. The upper surface is a plane, which is this is the equation, and here this is the general shape of the solid. Okay, but the upper surface is this one. Okay, z equals x plus 1 or whatever. Okay, the lower surface is the floor, either z equal to 0 or whatever, but the upper is the plane. يعني don't worry about هذا حيكون surface حيكون ايش الellipse or whatever. No, I need just the upper surface. Okay, you will see this solid in many times in the exercises, in the lecture note, in the exams also. So here the objective is just to help you visualize the solid, but at the end the upper surface comes from the plane, and this is ايش يعني the top of the cylinder comes from the plane. This is the equation of the plane. This is the upper limit of integration. Okay. So this is ايش? This is just يعني how to sketch this one. Okay. Now let me just mention something here. Okay. 57. Okay. Now if you have no question you can leave. Have a nice day. If you have a question you can ask now. Okay. You can ask.
دكتور
نعم.